first floor entrance lobby, like in the, right when you go in there. Okay, everybody's got that. All right, good. Okay, let's see. Draw and label the standard normal distributions. So I'm going to erase this. Any question about these equations? They're printed for you along with everything else. And how can you memorize equations like this? Put them on a 3x5 card and write on one side the variance of x, and on the other side you write the equation, and you've got a deck of cards, and you look at the side that says variance and write the equation and turn it over and check it, and if it's wrong, then mark it wrong, and keep going through the deck till you get them right several times in a row, and then do that a few times, like right before your homework. Pretty soon you'll be able to memorize it. So you just practice writing it out by hand, read the one side of the card, check it, make sure, see if it's right, compare what you did with what it is there, make sure everything's correct. All right, so the standard normal distribution, we chanted the areas under the standard normal curve. It's a bell-shaped curve, it's symmetric. The area between 0 and 1 is 0.34. It's symmetric, so the area between 0 and -1 is also 0.34. Between -1 and -2 is 0.135, and between 1 and 2 is also 0.135, and from 2 to positive infinity, it's 0.025, and from -2 to negative infinity, it's also 0.025. How many got that? Okay, it looks like most people got that. So you've been chanting the areas under the normal curve. And all the normal curve problems that you have, when somebody gives you a normal distribution and mean and standard deviation, you can convert them to the standard normal distribution. So, well, here's an example right here. So here's a problem with a mean and a standard deviation. Find the z-score. So z sub x sub I is x sub I minus x bar divided by s sub x. And so in this case, we're going to subtract 100 and divide by 15. So it'll be, the first one will be 85 minus 100 divided by 15. Is -15 divided by 15 is equal to -1. We got that? All right, good. Any questions about how to find a z-score? So you just substitute in, the questions gave you the mean, in this case, the standard deviation. But if they hadn't been given to you, you know how to calculate the mean, you know how to calculate the variance, you take the square root, you get your standard deviation. Then you can take a score and subtract the mean, divide by the standard deviation to get the z-score. All right, 130 would be 130 minus 100 divided by 15, that's equal to -30 divided by 15, that's equal to -2. Oh, +2, excuse me, it's positive 30 divided by 15 is +2, thanks. Don't let that, I'm glad you corrected it, because some people might have written that down, wonder where the negative sign came from. All right. Okay, any questions about that? Now we have a case where x is normally distributed with a mean of 100 and standard deviation 15, so that's just the same case as this. So what you do is you put the mean right here at 100, add one standard deviation. Standard deviation is 15, so that brings us to 115. That corresponds to a z-score of 1. Add another 15. That brings us up to 130. That's the value that has a z-score of +2, right, as we just found here. Subtract 15. That takes us down to 85. That's the value we just worked out there. Subtract another 15. That takes us down to 70. And so now you can answer all sorts of questions about IQ, which is normally distributed with a mean of 100 and a standard deviation of 15, because we've related it to our standard normal distribution. And so the question is, find the percent who scored below 85. Well, that's 0.025 or 2.5%. 2.5% or 0.025 as a proportion. How many got that? Any questions about that? So you needed to know the normal distribution, which apparently most people did. Then you needed simply to be able to convert this normal distribution into this one. by basically putting the mean here. Another way to do it would simply be to say, what was the, oh, well, that's the wrong answer. The question was 85, right, not 70. So I just gave you the right answer for 70. It's 70, that's 2.5%. 85, that's 13.5%. So we need to add these two together, and the right answer is 16%. Nobody grunted that time. So the right answer is 16% because the question was below 85. And I give you the just part of that answer, which is this 2.5. How many got it? Got 16%. Okay, more. All right, good. All right, go ahead and raise your hand if I goof up here on the board. All right, so 16%. And what percent are below 130? Well, that's everything except the 2.5. I guess I can get things backwards today. Everything except the 2.5 up there. So this adds up to 0.5. If I add 0.34 to it, that's 0.84. And if I add 0.135 to it, that's 0.975. Or I could realize the whole thing adds up to 1, and I would take 1 minus 0.025. Either way, I'm going to get 97.5%. How many got this one, okay? Any questions about that, how you do these problems? So the trick is, draw your standard normal curve, which you've memorized. Put the mean at 0, because you can see that when x is equal to the mean, the z-score is going to be 0, because this will be 0 divided by the standard deviation. Add 1 standard deviation. That gives you a z-score of 1. So the mean plus 1 standard deviation corresponds to a z-score of 1. These are the z-scores again, and these are the raw scores, the x sub I. All right? So you can label it in terms of raw scores, and this is the conversion to the standard normal distribution. Right? Questions about it? Any questions? That's the trick, basically, for doing this. Or calculate the z-scores and then simply compare the z-scores to this distribution, because this is in z-scores right here. So the other way to do it is to find the z-score of 85, which was -1, and then realize that to the left of -1 is 0.025 plus 0.135. Okay, so that's the other way to do it. Yes?
So we don't use like the z-scored chart in this class to compare?
You mean like a table that has all the areas under normal curve? No, I'm not going to give that to you, but when you take stat, they'll give you a chart. They'll give you tables like that. And I think I mentioned last time, one of the tricks to make sure you understand it is to give you a different chart during the test from the one that you had in your book. Sometimes the book will have a couple of different versions of the chart in it, but I'm not going to give that to you, but definitely when you take your stat course, they'll give you a chart to work with. But if you know these areas, then you have the chart with you. And so when somebody tells you, your child just took a test, the mean is 50 and the standard deviation is 10 and your child scored 65, you can immediately say, okay, so 60 would be 1 standard deviation, above means 65, so they're doing above the top 16th percentile. You know where your child is falling roughly without having to say, wait, let me take that home and look in my chart to find out, you know. So if you understand the mean and standard deviation of these test scores, talk to some mothers who are in consultations with their kids about why their child was being held back in school based on the means and standard deviations, and she said, they were talking about the means, she said, what's the standard deviation of the test? She knew the areas under the normal curve and said, well, basically what you're saying is the child is basically within 5% of the average. Why are you holding them back a year, planning to hold them back a year? And so she could immediately understand what decision was being made by a teacher that didn't really understand the test scores and know how to relate these to the normal distribution. She was able to do that, decided to take her kid out of that school, put him in a different school based on that, what they were planning to do with the kid. So when you're talking to the doctor, you don't have your chart with you. So it's a good idea to have these landmarks and be able to relate, reading the newspaper about test scores and means and standard deviations. When you're looking at the statistics and deciding which school to put your child in, they don't always give you the chart with it. So it's good to have like a picture of the normal distribution in your mind so that you can roughly know where these numbers are without having to look it up. But when you take a stat course and they give you something that comes out you know, with a z-score of 1.79 and they want you to find it to 3 decimals, then they'll give you that chart and they'll have you figure it out. All right? Okay. Let's see, any questions about the quiz here before we erase that then? All right.